Hi, dear Mac 114 students. This video record is a complementary part on mating constraints. In Inventor environment, assembly environment, to be able to position the components with respect to each other or with respect to a certain reference, we use either this tool of the software constraining tool. It is the classical constraining tool. Already introduced this tool at the age I had started talking about assemblies how many weeks ago. Said that if there are two flat surfaces to relate with respect to each other, then select this type, and either this solution or the other solution, face-to-face contact or parallel positioning. If the flat surfaces are not parallel, not say coincided, but inclined with respect to each other, then select this option and then input the inclination angle with respect to one surface for the other. If one surface is cylindrical, for instance, and the other surface is flat, then while using tangency constraint, can position the surface of cylinder, of course, together with the surface, the cylinder itself, with respect to relative to a flat surface. Of course, if the offset distance is written 0, then the surfaces will be tangent. In this solution, cylinder will be at the inside, tangent to the other, but say in the region of the other component. But this solution is selected, then they will be tangent at the outside. Or writing offset distance, can position a cylindrical surface with respect to another cylindrical surface or with respect to another flat surface at a certain distance. If the entity is an axis, and the axis of one revolved feature is to be positioned with respect to the axis of the other, then use this facility. If it is applied with 0 offset value, then the axis will be in alignment just along the same line of action. Say that in the jargon, the entities, the objects are coaxial. And using this one, can position one component as the symmetry of the other. Yes. Here, what is complementary? Well, today I'm going to talk about as one of the complementary thing, motion type constraints. Okay, motion type. If the part of the assembly there is a mechanism, one component is to move, okay, linear direction or about an axis, rotary type motion, then yes. To be able to make a simulation to say that this is a movable part, and while it is moving, then the other one also actuated by that component, use this type of constraint. Okay, motion type constraint. The other mating facility, it is say the newly added one. For few years it exists in the structure of Inventor, joint tool. Okay, I have already introduced you to this facility. I said that especially if the mating is the one it uses limiting positions, especially the component is to swing relative to the axis of the other, then especially for such a case, use this mating tool. It is recommended. Joint type, and then selecting the limits tab in the dialog, writing starting and ending angles, then can have the component as the one it can swing between two limiting positions. Actually, after studying on this example, it has motion type constraint, then I'm going to focus the attention to the other case. Okay, well, a component is to swing. Here it is the model. This component is to swing with respect to other. Talk about such a case. And then the other one in this record saying complementary things on mating constraints will be this one. Yes, well, we have a piston cylinder mechanism here. Okay, and there is a slot, and well, this part is movable part. While it is moving along the slot, then well, it is always to be in contact with the surface of this platform, and this one is to follow this channel. Okay, well, I'm going to talk about this geometrical relationship as well, but first study on this one. Okay, it is a sub-assembly. Well, to be able to make the components distinguishable, more distinguishable, I painted their surfaces. This component yellowish, this component is blue, and that component is a kind of brown. Okay, in that color. And at the browser, you see we have the corresponding icons: component 1, component 3, component 2. Okay. Well, if the components have been constrained, positioned with respect to a reference or with respect to each other, then using the constraining tools, of course, relationship tools, can see which constraints have been input for the components. Well, bring the cursor to the browser, and then over there find the icon it corresponds to the component. For instance, when I brought the cursor onto this icon, you see in the screen the yellowish one is being highlighted. Inventor changed the color of the boundary lines to red. Okay, from such a highlighting can understand that it is the corresponding icon to that component. And then, well, if you clicked on the associated cross, then yes, in the list you can find the icons, constraining icons. You see here, constraining symbol is on the tab, facility tab, and then, well, we have the icons, those correspond to the constraints which have been input, okay, as the relationship for this with respect to other. Okay, to be able to have a look at which constraints have been assigned for this component, and also to see the offset values or direction options, well, bring the cursor onto the icon, and then, well, when you do this, in the screen you can see a highlighting. This icon, this means mating icon, corresponds to the constraint. Well, from the simulation I see that the surface of the blue part and the edge of the yellowish part have been positioned using this constraint. What it is, right click the mouse and then say edit. If you do this, then Inventor will bring the same dialog. Okay, at this stage, being in such a dialog, the constraints have been input. Well, from the dialog box, I see that, well, the highlighted surfaces have been positioned with respect to each other. Well, the selected type is this one, and solution is this. and offset value 0. This means the selected surfaces, the surface of blue part, the surface of the edge of the yellowish part, have been positioned as face-to-face contact, being brought into face-to-face contact because offset value is 0 and the solution is mating against each other. Okay, close the dialog box. And then, well, understand how about the other. By the way, this is the icon, it corresponds to the first component, and cyan colored one is component 2. Well, since these two components have been related, then if you drop the list of the constraint symbols, clicking on the associated cross, you can see, well, for instance, mate 1. Since the same constraint is for relating this with respect to the other, the same icon with the same ID number and name will be in the list of the associated constraints for this component as well. Mate 1. To be able to edit that constraint, or if it is the constraint it has been input by mistake, so it should be deleted. Whatever the case is this. Well, for editing, either bring the cursor onto the associated icon for component 2 or for component 1. It is to find the same dialog box. Right click, edit, or bring the cursor here, right click, edit. It is the same dialog box. Yes, and this constraint can be found either in the list of component 2 or component 1. The other constraint, flash constraint, what is that? Okay, parallel positioning. Flash 1. Yes, the same constraint is for component 2 and component 1. Okay, flash 1 constraint, this means has been input for positioning component 1 and component 2 with respect to each other. So the same icon in the list of the constraints exists here and also there. Select one of them to have a look at, if necessary to edit, if necessary to delete. Right click the mouse when the cursor is on that icon and then select edit option. Yes, from the simulation in the screen I see that the constraint is the one, it is to bring the highlighted surface, this surface of the yellowish one, my cursor is moving over the surface, and the surface of the edge of blue one into the same plane. You see, flat surfaces positioning type, and that is the solution, flush solution. Parallel positioning. Since the offset value is 0, I see that this surface and that surface, the surfaces of the components have been brought into the same plane. They are in the same plane. Okay, close. And then flash 2 plus minus, flash 2 plus minus. If it is written next to the icon plus minus, this means limiting positions have been defined or input. What is that? Well, first hold this yellowish one and then drag the mouse. You see, I'm trying to move it further, but it is not going, because there is a limit for such a displacement. And in the other direction, trying to move the yellowish one furtherly in this direction, but it is being stopped at this limiting position, because there is a constraint. It limits the displacement of yellowish one, okay, over the surface of the blue one. Limiting positions. Well, since the limiting positions have been defined, well, in the vicinity of the constraint icon, we have plus minus. Okay. And then see what is that, which constraint has been input for positioning the yellowish one with respect to cyan colored one, blue one. Well, to find its place between those limiting positions. Bring the cursor onto this icon or onto the icon of the other component. These are to find the same things. They broke the same dialog box. Whenever this constraint, a constraint is input with respect to, for one component with respect to the other, then the same constraint icon is attached to the associated lists. For this, for that, you know this. Bring the cursor onto one of them, right click and say edit. Well, here, if you rotate the model, can see the arrows. These are to say this one with respect to other. Well, the constraint type is again for flat surfaces. Yes, this surface and that surface. Okay. Well, from the highlighting, I see that this constraint is for positioning the slender surface of the blue component and the slender surface of this yellow component with respect to each other. These are to be parallel to each other. Okay, so well, you see, parallel positioning option has been selected. But if there will be limiting positions, then well, the dialog box, when you start the constraining stage, you find the dialog box in such a compact size. Bring the cursor, if you bring the cursor onto this button on which we have much greater symbol and click, expand the dialog box and then find the limits option. Well, here this box has been selected, that box has been selected to write the limiting values. Well, the limiting position, maximum positioning 0 and minimum positioning minus 80. Well, some cases the sign may be confused. Try. Well, if it is to move in the opposite direction, then well, replace the positive constraint value, say positioning value, with a negative one, or vice versa. Here minus 80 is the minimum positioning. Maximum positioning is this one. Both of the surfaces are in the same plane, and it is a limit. Since there is a limit over here, then if someone attempts to move the yellowish one with respect to the other furtherly beyond this limit, no, it is impossible. It cannot be done. Well, the other limiting value, negative 80, well, relative to the coordinate axis, you see there is a ellipse over here at the bottom corner, z-axis. The displacement, this constraint is to position the components along the z-axis as parallel to the z-axis. So this is the positive sense of the z-axis, but the yellowish one is to move in the negative direction of z-axis. That is the reason why the offset value is written as negative. Okay? Well, if you confuse whether it is to be negative or positive, consider the coordinate axis. This constraint is to position the component in the direction of which coordinate axis? X, Y, or Z. Then, if the displacement it is needed to have is in the negative sense of the z-axis, then write the constraint as negative. Okay. Yes, that is the constraint, and thanks to the existence of such limiting values, C, we cannot move we can move it in this direction 80 millimeters, but in the other direction impossible. This is the limiting value. Okay? Yes. Limiting positioning. Yes. Okay. How about the other constraint? When I drop this list, well, I found for components 2 another constraint symbol, insertion type, but in the list of the component 1, constraining list for component 1, there is no such an icon. This means insertion type constraint has been input not to relate component 2 with respect to component 1, but with respect to another. Well, there is one more component you see. It is the brownish one, component 3. Okay, then drop the list of the constraint icons and then see insert 1, insert 1. Since the ID number is the same, insert 1, 1. From here can understand that this constraint has been input for positioning the brown component with respect to blue component. Yes. Isolate this one. Blue component have such a bearing part. Okay, it is of course I simplified the bearing structure of the bearing. Actually, if it were a more realistic assembly, then over there there would be either slide type bearing, sleeve bearing, or journal bearing, anti-friction bearing. Well, actually this week or latest the last week of the semester, next week, you're going to find a lecture note. It is about bearings. At the time, I'm going to deeply talk about bearings and the things to do in CAD environment. Assume that there is a bearing over here, and then yes, the brownish one is to rotate. Okay, as suspended by the bearing, supported by the bearing. How? To be able to make it distinguishable, I added such a cylindrical extension. You see, I am rotating the brownish one, and while it is rotating, the yellowish one is reciprocating. Yes, there is, because there is a motion type constraint. Motion type constraint. Before talking about this motion type constraint, then well, understand insertion constraint. Yes, the longitudinal axis of the brown component is to be in alignment coaxial with the axis of this bearing part. Yes, using insert type constraint can position the axis of one with respect to the axis of the other. You know this. Right click the mouse, after bringing the cursor on the insert icon, and then say edit to have a look at. Yes, I see from the dialog box, for positioning the brownish one with respect to the bearing part of the blue component, well, insertion type constraint has been input. Clicking on this, you know, we can position the longitudinal axis in alignment or at a certain distance with respect to the other. Here offset value is 0. This means, well, the axes are in alignment. Solution this or that. If one component is to find at the outside of the other, then select this solution. If the components are embedded, one component is to be within the other component, then select this solution, the aligned solution, depending on the case. For instance, if there were a roller type bearing within this say bracket, then the bearing would be within the blue part, and within the blue bracket part of the blue component, there would be a hole, okay, to house the bearing. Then to be able to position the bearing into the bearing house, I would use this solution. You see, when I select this solution, then the brown part partially found its place within blue part. Of course, this is the wrong positioning. Select the other. Okay. And then this example, the complementary thing, actually I finish making a review on such things already studied things. Now this is additional for the first time. Rotation type, or say motion type constraint. Well, while the yellowish one is reciprocating, please focus your attention to the brownish one, cylindrical component. It is rotating. Well, there is such a geometrical relationship, motion type relation, motion type constraint. While one of them is rotating, the other is to reciprocate, or vice versa. Imagine that a part of the cyan colored one, there is an electrical motor, and motor is to rotate the brownish one. While the brownish one rotating about its axis, it is to display the yellowish one. Well, if the brownish one were a gear, spur gear, actually last week of the semester, it is in the content, one of the chapter in the content, it is about gears. Okay, it is a very valuable chapter. Okay, we're going to study on that chapter next week, last week of the semester. Then, well, while the spur gear is rotating, thanks to the existence of a rack means a straight gear, well, the yellowish one can reciprocate. But here in this example, these are not gears. Well, the relationship is motion type, but here in this example, imagine that the surface of the cylinder is tightly touching to the surface of the yellowish one. And then when the brownish one is rotated, then, well, thanks to the existence of the tight touching between the surfaces, we will have friction forces, and the friction force, the tangential component of the force exerted by the surface of this brown one, is sufficiently large to move the yellowish component. Yes, this displacement is achieved thanks to the, in real life, of course, thanks to the existence of friction forces. Okay. Yes, we have friction forces. So thanks to the friction force, the created friction force, okay, while rotating, via rotating the brown one, can overcome the resistive effects, and then that friction force can display the yellowish one. Okay, that is the mechanism. How about the constraint? To be able to relate the components with respect to each other for having or making such an animation, such a simulation. Bring the cursor to the list of first component or to the list of the third component. Rotation translation 1, rotation translation 1. The ID number 1, 1, this means it is the same constraint. And in the parentheses, there is a strange number, 81.681. What is that? I'm going to explain. But first have a look at. Right-click the mouse and then say Edit. Well, from the simulation, you see I have arrow, but a banded arrow as well. And longitudinal axis of the brown one has been highlighted. And in the dialog box, I see not assembly tab, but motion tab has been selected. If one surface is cylindrical, the other surface is flat, then select this type. If both of the surfaces were cylindrical, then I would select this type. Okay. For instance, there are two spur gears, and these are, of course, one of them is to rotate the other. Both of them has cylindrical rims, so select this type and then input the constraint. But in our case, this example, the surface of the yellow one is flat, so select this type option, and then indicate the first component, feature, indicate the second feature, selection tabs. Which solution? While the component is rotating, if the other one is to move, okay, in the direction of the development of the revolved feature, then select this solution, okay. But here, while it is rotating in the counterclockwise direction, for instance, brown one while rotating in the counterclockwise direction, the other one is to move in this sense. Depending on the direction to have for the component it is to display, then displaced, then either try this one or the other one. Can find the correct option in the end. Okay. Yes. Well, the value 81.681. What is that? Well, if there will be no slippage between the surfaces, okay, well, there is a tight connection between the surfaces, so, well, the friction force has not been exited, okay, yet. So the maximum value of the friction, friction coefficient, dry friction coefficient times the normal component of the force, okay, it is just at the mating surface, acting at the mating surface, action reaction. If that limit has not been exited, then physically obvious, for one turn of the cylindrical part, since there will be no slippage, well, the displacement will be equal to displacement of the other one, it is to make rectilinear displacement, will be equal to the length of the perimeter. For one turn of brown one, what is the value of perimeter? Since there will be no slippage, there is no slippage, what is the perimeter value for the rotating one is, then the linear direction displacement of the yellowish one will be the same, will be equal to the diameter of the brownish one. Inspection tool and then see, indicate the age, and Inventor saying that diameter of this is 26 millimeters. Okay, well, diameter times pi is equal to the value of the perimeter. Okay, then this is my calculator, Windows operation system, the gift of Windows. Okay, calculator. Diameter is 26, yes, and then, well, the perimeter 2 pi r, or pi times d, pi times d is diameter 26, is equal to 81.861. yes, 81.861 is the perimeter. And then, well, turn back to here, rotation type constraint, edit it. Yes, distance written over here is the perimeter of the for the brown part, cylinder. Yes, that perimeter value is to be written into the distance box to have for one rotation, one turn, the displacement of the other one, it is to reciprocate in the corresponding value. Perimeter of the brown one is equal to the displacement of the yellowish one for one turn. Okay? Yes. And then, well, if it is rotated through 360 degrees, then the displacement of this one will be equal to 81.861. Well, at the browser, in the parentheses, the written strange value is actually the displacement value for the component it is to reciprocate for one turn of the other, or the perimeter of the rotating body. That is the meaning. Well, here I'm going to delete this constraint and then recreate it. Delete. Just to, since it is for the first time, just focusing your attention to this type of constraint. Well, start from the beginning and then indicate. Well, here you see I am reciprocating this, but the other one is not rotating because they are not related yet. Okay. Can independently rotate the brownish one or independently reciprocate the yellowish one. But while I am reciprocating, you see brown one is not rotating, or vice versa, because there is no motion type constraint yet. Okay. Input the motion type constraint. Well, click on constraining button, bring the dialog box, and then select motion type. And then, well, one surface is flat, so select this type. Okay. And this solution is the correct solution. And then at present distance is 1. Then the order selection tab 1 is on. Indicate which one first. Bring the cursor to the vicinity of the edge of this revolved body. Okay. See that highlighting is on the axis. While you're seeing such a highlighting, you see longitudinal axis is in red color highlighted and there is a banded arrow. Then say that it is the first feature, indicate with a click. And then the second selection button is on. Then indicate. Common mistake, not this surface. Well, students considering that, yes, these are tightly connected, so, well, that is the surface to which the surface of cylinder is in contact, so indicate the surface. No. While it is being rotated, the surface to display to observe whether it is displacing is this slender surface. Not this, but indicate that surface. And then, well, the calculation is achieved. Pi times d is calculated by the software, and into the distance box it is written automatically by the software. That is it. And then say OK. Of course, if you're going to have the simulation to say that it is slippaging, okay, limit of the friction force has been exited, while it is displacing, the brownish one is rotating with a greater speed. It is sliding over the surface, displacing the yellowish one, but via sliding over the surface. Then write a big number into this box. Okay, but if the number is the one, it is calculated by the software, it is just pi times d. Okay, then sure, there will be no slippage in the say consideration, and for one turn of brownish one, the displacement of the other will be equal to the perimeter of the rotating body. Just say OK. That is it. And then animate, hold it and drag. You see one turn, hold this, rotate, and see the displacement. Okay, this one is, I think, okay, clear enough, became clear. And then how about the other one? Well, two components. Well, one component is to swing. Okay, say that, for instance, it is the hinge of a door. While door is being opened, okay, together with the door, it is hinge is to swing. Yes, imagine that between the cylinder and the spin and the hole of the hinge, there is a clearance type fit. So thanks to clearance and to be able to further decrease the effect of friction, we further lubricate the contact surface using a kind of special oil, grease. Okay, well, friction force negligible and easily can swing it. In virtual environment, solid model environment, to be able to explain that, yeah, this is the component, it is not stationary, it is to move about the axis of the other. Okay, well, input the constraint. Well, similarly, at the browser, first find the icons corresponding to the components, part 1, part 2, component 1, component 2. Well, clicked on the listing arrow, and then you see the same constraint icon is in the list of both rotation 1, rotation 1. And since we have plus minus symbols, this means for this rotation type constraint, the limiting positions have been input. Okay. If it is the case, especially component is to swing between two limiting positions, then, well, do not use classical constraint tool. It is recommended use the tool of today for a few years, joint. Clicked on this, and then, well, if you're sure that the constraint type is rotational, yes, directly select. But if you're not so sure which kind of relation you have between the features of the components, then select automatic option. Well, while you're indicating the components, then clever software, user-friendly software, the software of today, contemporary software, new generation software, what it is Inventor, can understand which kind of joint over there you may have. Okay. Well, limiting positions. Well, select the limits option and then write angular constraints. Okay, now see which constraints have been input. Bring the cursor onto this icon, right click and have a look at the constraining stage which ones have been selected. Right click, edit. Well, rotation type joint. Okay, indicate, for instance, the bottom edge of this pin, indicate the bottom edge of the pinhole. Then, well, Inventor can understand that those edges are to be brought into the same plane and the axes are to be coaxial. Okay. And then here animation button, just to watch like a video film. You can see, clicked on this and then see, yeah, yes, it is to rotate. Okay. The limits, select limits option, and then, well, for this example, the current positioning, for the current positioning, the angle with respect to reference is 90 degrees. Starting positioning 0 degrees, ending positioning 90 degrees. Okay. Since the starting positioning, the angle is 0, since the current and also ending position it is 90, then this means the component can swing from 0 degree positioning to the positioning for which the angular value for that positioning is 90 degrees relative to the reference positioning, of course. Okay. Yes, this is the limiting position at which, for which angle, inclination angle of this component is 0. Okay, with respect to the surface of the other, this positioning it is 90 degrees. Okay. Clear, I think. Delete this constraint and then see what we'll have. You see there is no relationship. Okay. Then, well, input the constraint joint. Well, if you're not so sure which kind of joint, then, well, select automatic. But I am sure it is rotational constraint. So bring the cursor to the edge of the pin of the hinge. see this highlighting and indicate. Okay. Well, say that Inventor noticing me. First you indicated the grounded one. Well, say I forgot to inform you that, well, to be able to prevent this component from moving, you know the technique. Right, bring the cursor onto the component. If you need to fix the component at its existing place, then bring the cursor onto the component, right click the mouse, and from the menu it will drop, select grounded option. Well, it is the anchored component, so well, here in inputting the joint type constraint, the firstly indicated one will move while it is being related with the other to the vicinity of the other. Secondly indicated one will stay, first indicated one will move. So, well, forgetting that it is the anchored component, okay, when I input the constraint indicating this one first, yes, Inventor noticed me, saying that, yeah, that component has been grounded. Shall you make it as ungrounded? Continue? No. Well, change the order, indicate the age of this component first. Yes, bring the cursor to the age, indicate it first. And then indicate the base of the hinge pin. Yes. Then Inventor understood that these are in relation. And now the pinhole and the pin are coaxial. And then the rest, limiting positions, limits. Current position is 0. Starting and ending position, select this one. Starting position 0, ending position, say that 90 degrees. And then say apply. And then close this dialog box and then see. Yes, 90 degrees, 0 degrees. Okay, then this type of constraint is okay. How can input the limits for rotational type joints? And then the last example in this record is this one. Well, it is a sub-assembly, but there is a mechanism here, piston cylinder mechanism. One component is this one. If you want, I may paint the component. Right click and select edit option. Okay, I selected this one and I'm going to paint it. Thereafter to say that blue component, yellow component, etc. Select this color. Oh no, it is not so good. Which color? Dark green. Okay, why not? And then clicked on return. And then yes, paint this component, saying edit, without leaving assembly environment. You know, taking an editing right can have the selected component in part environment. Then you see, although still I'm in assembly environment, you see along the ribbon I have the 3D model part component creation tools. Okay, well, drop the list of this one, say to paint all of the surfaces. You know, it is addressed. Well, select this color. Okay, why not? Good, clicked on return button. And cylinder is the other component. Select cylinder and then say edit. And paint the cylinder with a different color. Light red. No, not red, light. Orange color, okay. And then clicked on return button. Don't forget to click on return button. It was one of the questions in the exam, said that why the student vanish in creating or doing something, because he or she forgot to click on return button. And then the piston is okay. I think it is in gray color. Okay. Well, related to this, say chassis, say that the blue one is the chassis, imagine the rest. And there is a platform here. Well, this piston cylinder mechanism, you see this one is to reciprocate. Yes. But here you see, well, when I attempt to rotate it, well, I had such a spreading out. It is okay, may occur, and then you can correct it again. Well, here observing the things in this direction, think about it. Well, this is to move, keeping the tangency relation between the end of this piston and the surface of the green one. But you see, it is try to see this right triangle, while the piston cylinder is like hypotenuse. If it is tilt angle is equal to that much, hypotenuse is greater. If it is over there, hypotenuse is smaller. You see, if the piston cannot display within the cylinder, okay, in alignment, then you cannot have this piston cylinder mechanism at this positioning. You see now, while it is moving in this direction, piston is displacing within the cylinder, and then it is like a telescopic antenna. Now the part of the piston it is at the outside of the cylinder is greater in length. At this limiting positioning, the part it is at the outside of the cylinder is smaller in length. To be able to have such an allowance, well, the constraint to input for the piston with respect to the cylinder is insertion type constraint. Well, okay, well, for this assembly, we have which constraints? One by one, check. And then it may be an home study for you. Try to have such a mechanism in assembly environment. Of course, if you have the software and if you have the computer. Yes, unfortunately, near to 40%, as I remember in this course, or even more, has no software in their old computers. Otherwise, well, the exam would be CAT type exam mainly, not multiple choice. For the closed book part, yes, it would be multiple choice, but the other part, it would be in CAT environment to test your learning outcome on CAT applications. But impossible because of Corona lockdown to test your outcome in CAT environment. Okay. Well, cylinder, yes, orange colored one is the cylinder. Guide is the green one. Piston, the gray component, and pin house is the chassis, blue one. And then clicked on the listing arrows, drop the list of the constraining icons. And then for the cylinder, rotational type constraint and mating, coaxiality. Well, mate one and see the list of piston, mate one, the same constraint. What is that? Right click and have a look at edit. Yes, this type, this solution, do not select well, this is important, do not select this insertion type constraint. Well, if you select this constraint, then well, you have the longitudinal axis as in alignment, but cannot display one component along its line of action of its axis. Okay, don't make such a mistake. It is really important. You see, well, although the axes are in alignment, but since the piston is to display in the direction of the axis of the cylinder, well, insertion type, no. Insertion type constraint is to position the axis of one component in alignment with the axis of the other, but the motion is impossible. Sliding will not occur, cannot be, cannot have sliding type displacement. If, well, one component, it has an axis, is to display in alignment with its axis with respect to the axis of the other, then select as if it were flat surface, this type, and then indicate the age of the cylinder, age of the piston. Then Inventor replaces the solution options, and then, well, here that is the solution. While it is moving in this direction, the other one keeps its position. Okay. And there is no limit, because I don't know when it is limiting position, the length of the part of the piston, it is to be at the, going to be at the outside, how many millimeters. I don't want to calculate this one, so I didn't put any limitations. Okay. If there were no tangency type constraint between this cylindrical extensions and the surface of the green one, then the piston might be just hold and then even moved to the infinity, because there is no limiting positions. Okay. And then, well, rotational type constraint for the cylinder. Yes, while it is moving, yes, while spreading out, I had one more time. Try to, yes, okay, restore it. While it is moving, yes, while it is making such displacement, you see, well, there is a pin joint over here. The end of the cylinder, we have a pin connection, and this is the pinhole. Imagine that I simplified this assembly. I omitted the pin, but well, imagine that there is a pin joint here. Well, the pin joint, well, to allow the cylinder together with its piston to rotate. Okay, about the axis of the pinhole, it is to rotate. And while it is rotating, you see cylinder just extending beyond the tip of the cylinder. See, it is parameters, right click and select edit option. Yes, rotational type, and you see here the age of the pinhole, the age of the other pinhole have been indicated at this stage, and then had the piston, had the cylinder at the place related to the this chassis part. Didn't input any limit, okay, because I do not know when this piston at the limiting position, what will be the angular displacement for the pinhole. The limits will come from the relation between this cylindrical part of the piston and the guide of the green part. Okay. For cylinder and piston, these are the constraints, but for the piston, well, we have two more constraints. flash one of them, 3 more constraints, sorry, flash, tangent, tangent. Okay, then study on those. Right click and edit. Yes, from the highlighting, to be able to have the end of the piston always as parallel with respect to the surface of the channel, you see that constraint has been input. The distance, well, try to rotate it, between this surface of the channel and that highlighted surface of the piston end is 5 millimeters. Okay, yes, this part between the end of the piston and the side surface of the piston end and the side surface of the channel, there's a clearance 5 millimeters. I said that these are always parallel in positioning. Okay, the other constraint, tangency, right click and then see what it is, edit. Well, from the highlighting I see that to be able to keep the end of the piston always in contact with the surface of the screen one, yes, tangency type constraint has been input. Indicated flat surface indicated the surface of this cylindrical extension, or it might be the surface of the other cylindrical extensions, not a matter this or that. These are in alignment, so at the same level. Indicate one of them. While at this stage, this extension has been indicated by me. It is to say that this cylinder and this flat surface are to be always in tangent. Okay? Thanks to the existence of this tangency constraint, then piston cannot furtherly move ahead in the axial direction. Okay? The other constraint, another tangency constraint, well, just to set a limit. You see, it is to move between these two limiting positions. How? How can limit the displacement of piston cylinder along the channel? Here is the answer, tangency constraint. Have a look at how. Well, that time indicated, yes, as one of the surface, this the surface of the cylindrical extension, but as the other surface, well, try to see, I indicated the not side but the limiting flat surface of the channel, and then I input a limit value. I said that minimum position 0, maximum position is 30. Yes, and then see which surface I indicated. Can you see this flat surface? I said that relative to this flat surface, it is to be tangent. But since I input the constraints, say not constraint, limiting value, I said that one limit is 0, the other limit is 30. Yes, 0 tangent, but 0 millimeters and 30 millimeters. Now, with respect to that surface, this surface of the channel, now the distance between the tangent cylindrical surface of the cylindrical extension and the plane of that flat surface is 30 millimeters. But this positioning, it is 0. Yes, so it can reciprocate. Okay, dear students, well, another thing here, well, as the last part of this complementary video record, it is, you see, about constraints again. Well, I want to provide one more complementary thing. Some cases the one component is to be positioned with respect to other. But say that in the design of the component there is no flat surface to indicate, to say that that surface position with respect to other surface. Instead of thinking too much which component may be suitable, I'm going to use the existing ones. Assembly template, open a new assembly template, okay, and then place two components from the project folder. For instance, one component is this one, the other component this component. Okay, one by one invoke, right click and then say okay. One component is this one, the other component, clicked on place button. It is the tool to invoke a non-standard component from the memory and say that this one, okay, why not, I may use it. Okay, yes, if the surfaces to position are the existing surfaces of the components, it's okay. Then, for instance, select this constraining tool and then say that this surface and that surface are to be positioned, or change the order, this surface and that surface. Yes, it is okay. But here say that not those surfaces are to be used for mating one component with respect to other, but any other. Say the other one, say case. For instance, work plane. Have a work plane. I'm going to make the demo selecting this as the reference and then say that a work plane. Have such a work plane over here. And then, mating issue. Instead of mating this surface onto that one, onto this one, etc., then say that the surface of this component is to be mated over here. Say it is an imaginary surface, but as if it were the surface of this component, it can be indicated. Indicate the surface. You see now indicated surfaces are in relation. A useful technique. While using work planes, you can position one component with respect to other. Keep in mind. Or say that not the once those can be invoked dropping the list and selecting. These are the work plane invoking options. Create a work plane. Take an edit right. Over the surface of this component. You know how a work plane can be created. Take it in edit mode and then select the surface, right click and then say new sketch and then draw a line. This line in my consideration is the edge of a work plane creation. Project geometry process, have the projection of this edge. Why? Because relative to this projected line, I know the inclination angle of the work plane it is needed to use. Dimensional constraint, from here to there, the angle, okay, for the work plane is equal to 38 degrees, for instance. Okay? And then finish the sketching stage and apply extrusion process. You know the trick. In the dialog box, do not select solid model creation option, but surface creation. If you clicked on this button, then can apply extrusion process for creating surfaces. Indicate the sketch and then have a work plane. Yes, the size of the plane is not so important. And then return back to the assembly environment, clicking on return button, and then say that the one of the component is to be positioned with respect to the other. How? Well, such that the surface of the component is to be in contact with that imaginary surface. What I mean here, in short, I mean work planes are imaginary planes, but they can be used for positioning one component well, with respect to the other, as if they were real features. Okay, for instance, face-to-face contact. Indicate what this work plane as one of the surface, okay, and indicate this surface of the other component. Yes, you see, now these are in contact. Well, manage to position this hinge with respect to this work plane. Okay. Another example, not work planes, but say that work axis. For instance, over this surface, define an axis. Longitudinal axis is not defined for prismatic parts. Okay, take an editing right, and then say that select this option, normal to a plane through a point option. Okay. First, over the surface, mark the piercing point for that imaginary axis. Okay, mark the point, and then, well, dimensional constraint. From this edge of the surface to this point, the distance is equal to that much. From this edge of the surface to the point, distance is equal to that much. Okay, well, position the point. It is the piercing point for the axis. Okay, and then, well, clicked on axis definition tool. Which one? Normal to a surface, and it is passing through a point. This option. Indicate the surface, say normal to this surface. Indicate this piercing point, and then have a work axis. Yes. Axis is not so distinguishable. It is in the simulation tiny, but yeah, it is over there. It is defined. Okay. And then return. And then see the rest. Well, for instance, this one, yellowish one, has a hole, and for the hole, axis is defined. But if there were no hole, then similarly, I would use a work axis. And then here the rest. Example. Well, the imaginary axis and the axis of this hole ought to be in alignment. Insertion type constraint. Okay, indicate the edge of this hole and indicate the work axis. Well, actually, where is the axis? I couldn't find it. Well, probably I forgot to click on OK button. Try to define the axis here. Well, through center of a circle or elliptical, through 2 points, on line or edge, intersection of 2 planes. No. Well, here, work axis tool in assembly environment is not suitable. So, well, turn back to edit mode, and then, well, define the work axis over there. Normal to a plane through a point. Indicate the point, indicate the surface, and then here is the axis. Axis is over there. Return. Okay, and then, well, I am sure I clicked on OK button, so input the constraint. Insertion type constraint, Okay, indicate the age of this hole, indicate this work axis. Okay, and then they will be in alignment, they will position with respect to each other. Okay. Well, sorry, here there is a trick. Well, if it is an imaginary axis, okay, then instead of using insertion type constraint, select as if flat surface, this one. Okay, so otherwise cannot indicate the work axis. If the axis is not the axis of a feature for which longitudinal axis is defined, then yes, do not select this one, imaginary axis. If you use work axis tool, this tool of the software, so had a axis, where is the axis? Rotate it and then see in the space, there is a thin line, it is the imaginary axis. Although the prismatic, rectangular prismatic part axis is not defined, you see using that tool, in part environment of course, had such a by definition axis, such an imaginary axis. Okay, but if it is just the work axis, not normally defined for the holes, for the revolved bodies, longitudinal axis is defined, you know, but for the rectangular prismatic, trapezoidal prismatic, work axis is not defined, axis is not defined, so need to use work axis. But whenever you use work axis, have a work axis, then although for positioning the axis, longitudinal axis, with respect to each other using insertion type constraint, since it is not a longitudinal axis, it is a trick really. Select this type, not insert, but as if flat surface mating. And then indicate this axis. Yes, now it can be indicated. And the axis of the hole. Do it again. Constraint. Select this type. Indicate the work axis. Indicate the longitudinal axis. Yes, now these are in relation. The axes are in alignment. If you change the order, you know, the secondly indicated one, firstly indicated one moves, secondly indicated one stays at its existing place. This type indicate the age of the hole while you're seeing the longitudinal axis simulation. Indicate the work axis, and then yes, now the axes are in alignment. Okay, well, the last part of this record, what I said that if necessary, you can use work planes to position the components with respect to each other, or work axis. There is no axis. Axis is not defined for one component. Okay, then have a work axis, and then use that work axis to bring the component with respect to the other one. It has an axis or work axis in alignment. Okay, now finally ending this video record. I hope I achieved to provide the valuable complementary things, my dear students. Well, have a break. Stop here. In the content of the last week, well, can find the complementary video records. There will be 2 more video records. One of them is just about the lecture on threaded parts, threaded features. The other one, the corresponding CAD applications. Okay, see you then. In watching those video records. Bye bye.